Well, as part of project cost management, in this video clip, we'll talk about reserves and accuracy within the process of cost estimating. Reserves are recognizing that there are knowns, known unknowns, and unknown unknowns. This is risk management. This is sophisticated risk management terminology. Knowns are the things that you know will happen or that you're planning to happen. It's the base case, so to speak. But there's uncertainties. Known unknowns are the uncertainties that you can imagine. You know that some things are going to cost more. You know that some things are going to cost less. And there are also some things that you've forgotten to estimate that you will have to spend. Or that some surprises come up that will require some extra money. All of the things that you can imagine spending money on, or the risks that you can imagine could happen, are known unknowns. You know some of them will happen, you just don't know which ones. Now, there's also potential uncertainties or surprises that could not have been imagined. And those are unknown unknowns. It would not be reasonable for you to think of some risks that might happen because they're so unusual. A good place for a further discussion of known unknowns and unknown unknowns is within the project risk management knowledge area. Let's move on. So we have contingency reserves. These are for known unknowns. We will have made some errors in our early design or our estimating or our planning. There may be some things that we forgot to include. Oh, we didn't realize that this government agency has to approve our design. Oh, that's going to cost a little bit of money for us to put together that approval package and pay a fee. And there's going to be other uncertainties. These are things that we can think about the potential of when we're planning. As I say, we know some of them will happen. We don't know which ones. We have to have some money in the budget for those kinds of surprises. Now, something that is a rather important part of reserves, at least theoretically it's true, that contingency reserves should not be for scope changes by the customer, scope additions by the customer. Because if I put money in the budget, if I put money in the estimate for unknown scope changes that haven't been proposed yet, essentially I am approving those scope changes before they've even been approved or before they've been discussed. So if a scope change makes business sense to the customer, that's the time to say, here is the extra cost associated with that scope change. Now, I say that it's important theoretically that contingency reserves are not for scope changes by the customer. Real life is sometimes not quite so simple. Here's another important theoretical part of contingency reserves, which is that it's controlled by the project manager. I'm quoting a project management authority here, Bill Duncan. He says, spending contingency reserve by you, the project manager, does not require approval by the sponsor or the customer. It's already part of the budget. It is already in there to cover certain things, you just don't know which ones, so it does not require approval by your customer or your sponsor because it is part of your project budget and it's controlled by you. Now again, real life is sometimes not quite so simple. And when we are estimating contingency reserves, the Association for the Advancement of Cost Engineering puts it well. It says the contingency reserve on a project estimate means how much do you have to increase the estimate to make it realistic. Because if you have a tight estimate of all of your work packages and you add them up, it's not going to be enough. Some of those work packages are going to cost twice as much. None of them is going to cost 100% less, and there are going to be some surprises. So for the whole project estimate, you have to add in some contingency reserve to make the whole estimate to be realistically achievable. And depending on the context, the estimate that's reasonably achievable could be a 50% achievable estimate, or it could be a 75 or 80% achievable estimate. A good place for further discussions of this is also within project risk management. But when we are preparing our contingency reserve, there is the danger that there'll be contingency on top of contingency. In other words, you get your work package leaders to estimate each one of their work packages, and they may very well add some contingency into their estimate for their work package. You probably don't want them to do that. You probably want them to estimate tightly for each work package, and then you add up the work package estimates, and then you add on a contingency on the overall estimate. And you also see the bullet point to my left, expected to be spent. Well, I do not mean by that that you should spend the contingency. I mean that given the context that I've just described about the purpose of contingency, we have to recognize there is the likelihood that some of those things will happen such that it will be used up. It should not be a surprise that the contingency reserve is spent as part of project costs. Now, if it is not spent, that's wonderful news. If you don't spend your contingency, that's great. It means either your organization makes greater profit on a fixed price project, or you keep the cost down to your internal or external customer. Now, there is the other kind of reserve, which is not quite as commonly talked about. Contingency reserve is very commonly talked about. Management reserve is not so commonly talked about. Management reserve is money that your management or your customer has in reserve as well as the project budget. You do not have the management reserve. Your customer or your sponsor has the management reserve. You probably don't know how much it is. And it's for unknown unknowns, or it can be for scope changes. Sometimes a customer, let's say you're doing a project for an external customer, and that customer is taking your quotation or your estimate and appropriating some money within their organization to carry out the project. They may appropriate some additional money as management reserve, so that if there are some scope changes or some unknown unknowns happen that make my project more expensive, they have the money readily available. They don't have to go to their board of directors and requisition more. I'm quoting the same Project Management Authority, Bill Duncan. Management reserve may not have to be expended, and if it does require approval from your sponsor or your customer. Now, coming back to the contingency reserve, which you are responsible to estimate and then to manage, how do you calculate the management reserve? Well, quite a common method in most application areas is a percentage of the whole estimate. Like in your organization, for these kinds of projects, maybe we estimate the project and add in a contingency reserve of, say, 10%, or maybe it's 20%. In fact, in some organizations or some types of projects, it may be that you estimate the project and then you add on 100% of that estimate as a contingency reserve. It could even be as high as that when the uncertainty is reasonably high. Now, you could be more detailed. You could look at the project and look at the estimate or the budget and break it down according to riskiness. We'll look at that on the next graphic. To calculate contingency reserve, you could use Monte Carlo or other Monte Carlo simulation or other simulation method. A discussion about this would be appropriate in project risk management, and really it means it's a way to take the single point estimate of the project and raise it to a percentage achievability which you and your customer find appropriate, such as 50% or possibly 75%. Now, once you have calculated decided on the amount of a contingency reserve, it's a good question as to where do you show that contingency reserve in your budget. Well, the most common way to do it is as a single line at the bottom of your written budget, contingency reserve. And you can look at the dollars or labor hours and see that it's 10% or some percentage like that. Another way to do it, particularly if you are looking at the riskiness in various sections of the budget, is to assign contingency reserve to sections of the budget. Or it could be you're assigning contingency reserve, a contingency reserve amount to each phase of the project. And for example, during the design phase, you have a 10% contingency. During some sort of production or development phase, maybe it's 30%. Now, what is probably most commonly done is burying the contingency reserve in each budget item. That would not be recommended. If you give Mary a work package and her work package really should cost $9,000, but you've distributed your contingency reserve to all of the work packages, so really what's approved is $10,000 for Mary. Let's face it, chances are Mary is going to spend that $10,000 and congratulate yourself on being on budget. But she's not. You really wanted her to do it for $9,000. Maybe you need that $1,000 for something else that's come up. So I'd recommend having tight estimating of all of the work packages and then have your contingency reserve, either as a single line at the bottom or distributed through the budget by section. Now, of course, it can also be hidden. I could have a line item, particularly if I'm, let me start that thought again. If you do have a single line contingency reserve at the bottom of your estimate and it's $1 million project, maybe it's $15,000 as a contingency reserve. Your customer or your manager looks at it and says, hey, we'll take it without the contingency reserve. We'll save ourselves $15,000. Well, you're not willing to do the project for $15,000 less. You need that money. So you may be tempted to put in a line item and hide it somewhere in the budget where nobody's going to know it's there. I don't recommend that. I think I always like to assume that I'm working in an organization where project management and our project management methods should be explicit. We should be encouraging discussion about risks and how we're handling that risk. And I don't want to develop the reputation that in the future somebody says, well, don't worry about those extra costs because Ferndale he's got hidden contingency somewhere. I'd rather be explicit about it. So here's a way of calculating the contingency reserve by budget section. Section A of the budget somehow is catalog items. You know what you're going to purchase, you're pretty certain as to how many and what color you want, very little uncertainty, but you do put in 2% perhaps. Then there's another section of the budget which is also low risk, high level of definition, small amount of contingency. Here's some medium risk items, maybe design work and you add in 10%. You take 10% of that as contingency and so on. And here's some high risk items that you won't really know until you get there. So maybe you take 15% of that section of the budget and you're able to come up with a whole amount of contingency. When it comes to discussing with customers and managers, you have a good reason. You have a good reason to justify having this contingency reserve in your estimate. Now, what about accuracy of estimates? This graphic is from the Association for the Advancement of Cost Engineering. They're very good in cost and scheduling tools on engineering projects. And this illustrates that if somebody gives you a half a day to develop an estimate on a project, you're going to have a pretty high range of costs. You're going to come up with $1 million estimate maybe, but you're going to be saying, hey, it could be 100% more or it could be 50% less. High accuracy range because of the low level of definition. In fact, you may say to your customer, if you want an estimate that's going to be plus or minus 10%, then maybe we have to spend several weeks of project planning in order to very carefully do early engineering, define the scope well, develop a pretty firm plan, and come up with an estimate that would be that kind of accuracy range. And if you, the customer, expect an estimate that's going to be completely accurate, well, the only way you're going to do that is to carry out the whole project, find out what it costs, and then you have that with complete accuracy. So here's an example classification of estimates. It's impossible to find this kind of classification system that's relevant for all kinds of projects. But in doing a little bit of research, I find that the industrial engineers have defined certain classifications of estimate by accuracy. This comes from an ANSI standard, which is industrial engineering terminology. So if you call something an order of magnitude estimate, maybe that means that the actual cost might be 50% more than you have estimated, might be 30% less. And you're probably using fairly top-down estimating tools like an analogous estimate or a factored estimate without a lot of detailed work being put into the project. In a project, if you're proceeding along a little further and you produce a budget estimate, this would be an estimate for approval of the project. It's going to use more quantitative information. It could be parametric based on some measurable characteristic. It might be detailed bottom up. And the industrial engineers suggest it might be -15 to +30% to accuracy. Or a definitive estimate would be bottom up. It's a well-defined scope, it's a work breakdown structure. You may be able to get -5 +15% accuracy. And as I say, definitely bottom up. The important thing is that in your organization, that there is a way for you to express the accuracy. You could express the accuracy of the estimate by saying percentages, -30%, +30%. You could explain the accuracy by saying a range, $900,000 to $115,000. Or within your organization, maybe there's a common understanding of what labels mean, like budget estimate, order of magnitude estimate. The important thing is that when you do publish a budget, that there is a clear understanding of the accuracy associated with it. Here's another example of estimating accuracy classifications. This comes from the Treasury Board of Canada. Quite a few years ago, Treasury Board of Canada is in charge of spending money for the federal government, particularly for projects. And they wanted a way for their consulting engineers and their design architects to have a classification system around public building projects. So they came up with this system, and it still lives on in commercial and government projects. So Class D would be an early estimate. It would likely be analogous or parametric. Class C would be a budget estimate now, notice here, they do not say what the accuracy percent range is. Instead, they say a budget estimate might have 15 or 20% contingency built into it. And a Class B estimate has less contingency because the detailed design is perhaps 60% done. Class A estimate is basically a fully detailed project with quantity takeoffs as if a contractor was quoting lump sum, so a small contingency amount would be applicable. I just give these as examples. They may or may not be relevant to your particular project. Here's another one. This is from the American Association of Cost Engineers. They're particularly strong in electrical and other kinds of utility construction and process plants. And their estimate classes go from Class 5 down to Class 1. Each class suggests a level of project definition. I think you could take that to mean percentage of engineering done, percentage of engineering design done. And they connect that estimating class with the likely usage of it, the method that you've used, and a description of the accuracy range that's likely associated with that method. So this is quite commonly in use within Canadian consulting engineering firms that do industrial kinds of projects. And that's reserves and accuracy within project cost management.